The next project is this 2017 BMW F30 330i XDrive. And if you notice a number of tools and miscellaneous parts on the floor, that's because we're jumping directly from the F10 M5 IBAC lowering spring project into this pre-owned post-delivery maintenance project. And actually this is going to take on 2 phases. I'm going to replace the front brake rotors, pads. Actually, I'm going to do pads on all 4 corners. I'll explain more on that later. But I'm going to do the front rotors and also the front thrust arm bushings, or what is known as hydro bearings. This vehicle is going to my youngest son. He's going to take possession after I get the first phase of the project done. And then in a couple of weeks, I'll get the vehicle back and I will do what I would do to any pre-owned vehicle, and that's go through everything. The list is something like this: the ZF 8-speed transmission service, the transfer case service, as well as the front differential, rear differential, and of course things like filters, you know, engine air filter, cabin air filter, oil and oil filter. And I'll do a brake flush, as well as replenish the coolant, do a coolant flush and refill. So there's just a whole list of things, and I'm going to try to get as much done in phase 1, but most of it is going to come in phase 2 in a separate video or video series. That's the scoop. The car it's dirty right now. It's been sitting outside in the rain and it's dusty and just not very pretty at the moment, but we'll get it cleaned up after all of the maintenance service is done. And it's a really nice vehicle. I was super pleased to get this. So we're gonna do what we can here in phase 1 and get this vehicle up to par in its service. I pretend as if nothing's ever been done. I don't have the service records on the vehicle, although it was a complete clean Carfax, 1 owner, and all of that. So everything checked out. It is a November of 2016 build. So again, this is a 2017 model F30. And that's it. Enough commentary. We'll move on to the first step. The vehicle is now on the lift. I have the front wheels removed, and let's talk about a couple of things before I get into the first finding. When test driving this vehicle, I spent probably an hour putting the vehicle through its paces. I connected a laptop, ran diagnostics. I also had the dealer put the vehicle on a lift where I could get underneath and look over everything. And the only thing when driving was a brake pulsation in the front. And looking at the rotors, they look pretty corroded, pretty rusted from what I could see. You know, I didn't get to take the wheels off or anything at that point, but that was the only concern. So I'm bringing the car home. I've ordered all the necessary parts, front rotors. I've got actually new pads for all 4 corners. And now that I have it apart, I can see immediately what has occurred. And that is, when brake service was done on this vehicle some time ago, they used aftermarket parts. And the dead giveaway here is the corroded hub, and look at all the rust. And even looking at the swept area of the pad there, it's not, it doesn't look like it's making full contact. And the pads themselves, well, they're BMW pads, but they are not BMW rotors. And I will show what BMW rotors look like. BMW rotors look like this. They always have a painted hub, and there's some corrosion there, but this has even a better swept area. These are the rears, and you know, it doesn't look bad at all. Now, I'll walk out and look at another F30, just as a point of reference. And this vehicle is a year older, has similar mileage. And there's the fronts. Okay, so a little bit of rust starting to show, but you can see that the inner hub is coated, and look how wide the swept area is. It's huge compared to the other ones. I'll walk back here and look at this as well. Yeah, you see a little rust starting to come in, but you know, the vehicle is going to need brake service here. I don't know. probably 10 to 15,000 miles or something like that. But look at that swept area, nice and clean. The pads are making great contact. Now there's a little bit of a ridge here, just a tiny ridge on the rears. So I think that's what I would expect to see, but when you get into aftermarket parts, this is what happens. You end up with crappy front brake rotors, which they did use BMW pads, but the pads don't have anything to bite into necessarily, or anything good to bite into. Now, just look how nasty that looks. And again, the swept area is so much smaller. So the pads themselves, I think the thickness is okay. Of course, I'll know much better when I get them off the vehicle, but that's the scoop. We're going to get these nasty, terrible aftermarket rotors off. Put a set of factory rotors on it. And BMW rotors are not the only ones that are coated and they're nicer, but that's what I'm using. And I'm not going to use BMW factory pads. I'm using, or will use, BMW factory rotors, and I'm going to use Hella Pagid pads, which are actually the same compound that BMW used on like the E90 series vehicles. Prior compound that has a little more metallic content. It's not a full metallic pad, it's not a racing pad, it's not an anti-dust pad. It's just a good pad with a lot of friction coefficient. That's what we'll be putting on the vehicle. I'll be putting new pads on all four corners, just doing the front rotors for now, and we'll get this in order the way it should be. And that along with, I'm going to replace these hydro bearings. This is the thrust arm, as it's called. I'm going to replace those hydro bearings as well, because they're probably worn out, and with what's going on with the brakes here, it's really giving those a workout, and it's going to be so much better when I get it done. So looking forward to jumping into this. On to the first step. The front brake rotors, pads, and caliper brackets are now removed from the vehicle. Let's take a look at the prosecution's evidence. As previously mentioned, the issue or problem with this equation is the use of aftermarket parts, and specifically the front brake rotors. The rotor on the driver's side, it looks pretty bad, and the rotor on the passenger side looks even worse. So it's obvious that the outboard pads are not biting the surface of the rotor. They're just more or less along for the ride, and you can tell this by the lack of swept area and all the corrosion and rust around the perimeter of each rotor. Not a pretty sight. Now, what likely happened is the owner, the prior owner, took the vehicle to an independent shop, and the independent shop sourced parts from a local auto parts store, Napa, CarQuest, AutoZone, Advanced Auto, you name it. There's tons of those shops out there, and they sourced the least expensive rotors they could find. Interestingly, they used BMW brake pads when doing the job, most likely because they couldn't find an aftermarket equivalent, and that's not surprising. But the rotors they're a little bit easier to find. And not to knock on independent shops and auto parts stores and things like that. There are better choices. There are plenty of selections all up and down the quality range, but they're really looking to get the vehicle in and out the door for the least amount of money, so they went with the cheapest alternative. And the real issue here is, when you look at the pads, the inboard pads are, well, they're just eaten alive. They're wearing at an alarming rate for where the vehicle is in terms of mileage and when the brakes were done and all of that. This would be a situation where the brake wear sensor would trip to tell the owner that the vehicle needs new brakes before the actual brake service indicator would come on. And it's usually the reverse. The brake service indicator usually comes on before the wear sensor trips. The problem here is this, whatever kind of metal this is made from, or whatever hardness it is, again, I'm not a metallurgy expert, but they are basically eating the pads. The pads and the rotors are not compatible. So that's the issue, and I'm going to take care of this straight away. We've got BMW Factory Rotors to go on the vehicle, and we have helipagid pads, and I'll talk a little bit more about that as I get to that next step. The new BMW front factory rotors are installed. The caliper brackets are back in place, and I have made an effort to clean up the hub, the caliper bracket, as well as the caliper itself. Much of the rust and corrosion was the result of these hideous aftermarket rotors. So you can see much of the rust and debris on the floor. Actually, there was a lot more. I cleaned it up a little bit, but point being that this is much more presentable and a good place to start to get things back together. The caliper bolt itself, it's 16 Newton meter tightening torque. I always use a Loctite, and I usually over tighten these, but there's no harm in doing that. Let's walk around to the driver's side here and have a look. There is some part number information on the hub of the rotor, and I believe these are 312 millimeter in diameter. This is a standard vented rotor. Again, this is a luxury premium model. It's not a sport model, not an M Sport or a full-on M. By comparison, the F10 M5 has 400 millimeter front rotors, 396 millimeter rear rotors. So this is very much a standard vented rotor for this vehicle. Now let's talk about brake pads. And I mentioned this before. These are helipagid pads, both front and rear. Although I'm not doing rotors for the rear, I am doing pads. Now, the backstory is very simple. In 2012, when this chassis, the F30, came to market, BMW went to a organic content dustless pad. German cars are renowned for their dirty wheels and especially brake dust on the front wheels. To mitigate this, BMW went to an organic pad. Now that's fine from an aesthetic perspective, but it took away some of the brake feel, especially the initial bite, or when you're depressing the brake pedal, you can tell that there's not quite as much brake feel at that point, and especially in the last 10 to 20 feet of travel when you're coming to a stop. And for someone who's driven BMWs for years, it's really noticeable. If you're a new BMW owner, you wouldn't know because you haven't had the experience. But what am I doing here? Well, I'm going backwards in time in terms of the pad compound to get back most, if not all, of that brake feel that was lost when BMW went to the dustless pads. What are these? Well, first of all, BMW has used a number of brake suppliers over the years. ATE out of Germany is a big one. TRW is another one. They haven't used anything from Brembo to my knowledge, but I believe at some point Pagid was an OEM supplier. Can't be 100% sure of that. Nevertheless, the compound of these pads are, they're semi-metallic. There's no organic content, and they're going back in time in terms of, with regards to dust. They will dust the wheels, but they are much better from a friction coefficient and in terms of what you feel at the brake pedal. I really like these pads, and the reason I know I like these pads is because for the past few years I've been running these pads on that silver 330i XDrive on the driveway. It was one of the first things I did after taking delivery of that vehicle, was to get it back to true BMW brake feel. The Pagid pads have really allowed that to happen. So if that's what you're hoping to do or would like to do, then this is the pad for you, and I hope this is helpful. These are just, again, you're going to have dust on your wheels, but you're going to have much improved braking, and these are the proper fitment for this vehicle. and we'll move on to the next step. At this juncture, all of the necessary brake hardware is installed. The brake pads, the caliper, the guide pins on the back side, as well as the spring clip are back in place. In terms of the guide pins, I always use the caliper specific grease on the guide pins as well as Loctite on the threads. So those are all squared away. I also use Crc Brake Quiet. It's a compound, basically an anti-squeal compound for brake pads. Now, I'm kind of doubling up here. It's really not necessary, and these vehicles are not known for brake noise or brake squeal, but you've got the metal part of the pad itself, and then you have this, what I'm guessing is Teflon or some rubberized material. It's a layer that helps prevent brake noise as well. So I'm taking it to the next level with yet an additional compound. Again, not necessary, it's just the way I do things. Spring clips, they actually, I intended to replace these, and these are on here temporary until I get the correct part. Long story short, I was given or supplied the wrong part. And backstory on this, I've been doing 4 to 5 major automotive projects back to back for several weeks now, and I had amassed a giant number of parts in various boxes, and the boxes for this project, I did a very quick count just to see if I got everything, but I didn't do a thorough audit of every part, and they gave me the wrong thing. Now, on that note, I mentioned earlier that Brembo was not a brake supplier to BMW, and I was obviously wrong. Now, these are the wrong parts for this vehicle. I'm not sure what that clip is on the right, but the guide pins on the left, those are for M Sport or M Sport models, and although these are BMW branded parts, they are obviously from Brembo. So anyway, learned something new there. They were not a supplier back in the day, but things have changed. So let's talk about the driver's side. So all the things stand true or are consistent over here, with the exception of the brake wear sensor. So you've got the weather pack right here, and you want to make sure that everything is plugged in properly and snapped back together. And then you want to make sure that the wire loom is going through all of the necessary standoffs. That's pretty obvious stuff if you're doing a brake job. And again, as I preached in a prior video or a couple other videos, you want to make sure that is the actual brake wear sensor is snapped into the inboard pad or the piston side pad. So, and it has to snap. It has to be in there firmly. If that's not in there firmly, and or the wire is not plugged in up here correctly, you will not be able to reset the service reminder. So just be aware of that. It's something I learned many, many years ago. And then in terms of, moving on in this project, I will be doing the thrust arm bushings next. And these, again, these are the hydro bushings. I have them here in the box, and yeah, they look like that. So you can use a press to remove the old ones and install the new ones, but I'm going to do this on the car. I have a kit of fittings and all the things I need to do this without removing it from the vehicle. So I'll disconnect it here, I'll drop it down, and then I'll get access to it. It'll be pretty straightforward. I mentioned earlier that I'm just doing the rear pads, and now I'm kind of thinking I might do the rotors in the rear as well. Initially I was thinking it's really not necessary, although I'm going to have to measure the rotors, the thickness in the back. But as with any BMW brake project, the process is pads and rotors, always. The difference with this vehicle is we're sort of in the middle of a brake service, or the need for a brake service at the rear. And I'm going to think about that a little bit more. I may just go ahead and get the rotors and do it properly, but the pads are still here in the box on the floor. I am performing an oil change on the 330i XDrive, and I have each of the 3 engine covers positioned on the floor. I also have the oil catch basin in place. Although the oil has already been drained from the vehicle, we are good to go there. And I also have this step ladder, which I'll explain in a moment. This is the first oil change since taking delivery of the vehicle. Just a good idea to get fresh oil and filter in the vehicle and start off on the right foot. Let's take a look at the engine. So this is the B46 engine. This is part of the new modular engine architecture from BMW that was introduced in 2017. This is vastly different from the N26 engine that is in our just 1 year older 2016 328i XDrive. And I'm going to do a separate video segment comparing the engines, everything big and small, all the little nuances. It's a very interesting topic. There's a lot to cover. A couple of those things relate to oil changes, but I'm going to get into those right now. We'll save the rest for later. Now, on all BMW engines, with the exception of the V8s, the oil filter housing has always been in this position, in the front of the engine. You know, whether it be an inline six, turbo or naturally aspirated, the turbo inline four engines that came into existence in 2012, the oil filter housing is always right here in front of the engine. You raise the hood, it's easy to reach. It's where it should be. The only thing you have to look out for when changing oil on those vehicles is not to allow oil to drip down into the alternator below, which on this vehicle, the alternator is in the same place. Where did they move it? Well, they moved the oil filter housing to the right rear of the engine, and they've also reduced the diameter of the oil filter housing. They're using a smaller filter, and it's just not as easy to access this. You're going to need a 27 millimeter socket with a swivel. You can't get to this straight on, and that is going to remove the oil filter housing cap. Let's talk about the oil filters. So we've got old and we have new. Now in terms of the old, this filter has been used in BMWs for eternity, going back to the late 80s, 90s. I mean, all the inline six engines use this. The Turbo 4s that came into existence in 2012, they use this as well. And even the new turbo inline sixes are using this filter. I did an oil change on someone's X5 the other day, and same filter. You also get the full kit, so you get both of the rubber O-rings, the green inner and the black outer, and you get the copper crush washer for the drain plug. Very, very typical standard BMW stuff. The new filter, it's completely different. It is made almost like a BMW M filter. So it has this black plastic, I don't even know what you call it. It's like, I guess it's nylon or whatever material they've used. It's a rigid construct, and you've got this kind of this felt-like material on the top that kind of binds it all together. But the point being that this is a much different filter, and it's more narrow, the diameter is smaller. And when you hold it up against and compare it to the old filter, there's not a tremendous amount of difference in terms of filter paper or filter media surface area, but there is some, and the older filter is larger. In fact, this filter, the new filter, reminds me of, with the exception of this rigid core, it reminds me of a oil change that I did on a Kia Stinger recently. Same size filter in the Stinger. They don't have this dowel-like thing or this plug-in on the end, but the rest of it is almost the same. Nevertheless, this is the new filter for the B46 and B48 family of engines, and we'll be using this going forward. Just got to get everything put back in place, get oil in the vehicle, and it does take 5.3 quarts of oil. Synthetic, I'm sure it's calling for 0W20. I'm using 0W40 synthetic, and that's just how I roll. I put that in everything. Lawnmowers, small engines, automobiles, it works wonderfully. We'll move on to the next step. I intended to mention 2 points. First of all, why am I on a step ladder with the vehicle elevated and the catch basin underneath? And that's because when you remove the filter cap and you pull the filter out and everything of the housing, that creates a vacuum release and oil runs down through the engine and out the drain plug. So you're going to get some additional oil out of the engine if you do things in that order per se. Be aware, on this new filter, in BMWs of old, I would snap the filter into the cap and then put the cap and filter into the housing. It doesn't work that way. You actually have to snap in this right here. That goes in the back of the filter housing and it snaps in place. So you're going to put the filter in the housing first and then spin the cap on. So that's a different order, a different way of doing things. And a quick look at the filter snapped into the housing and its proper orientation. Now the cap goes on to complete the process. Moving on to the next step of the project, which is suspension related. The forwardmost under tray of the vehicle has been removed, as well as the corner under trays or winglets, whatever those are called. And those are located on each corner, front corner of the vehicle. And by removing all of the under trays, we have exposed the thrust arm and the thrust arm bushing, or what is also referred to as the tension strut and the hydro bearing. The goal at this step is to remove and replace the hydro bearings, and the reason is wear. When under braking, the vehicle is putting a lot of energy and force through the thrust arm and into this bushing. The bushing is aluminum to rubber to aluminum, and it's filled with hydraulic fluid. This is really about pedal feel and reducing brake pulsation and brake shudder and all those things. A lot of people will chase a brake pulsation issue. They'll start out with the rotors, then they may go to wheel and tire balancing, road force variation balancing. They may swap out the axles, they may swap out wheel bearings, you name it. And many times the root cause is this hydro bearing, okay, this bushing, because it really takes a beating. And this is a huge bang for the buck to swap this out and restore that wonderful new car pedal feel and just the entire way that the car sits and feels on the road to the driver and to the passengers. It's not just, you know, what's coming up through the brake pedal or through the steering. It's really transmitted throughout the vehicle. So again, huge bang for the buck, and I highly recommend replacing these. I have done literally probably a couple of dozen of these on vehicles over the years, and not just BMWs, Mercedes-Benz as well. And on this vehicle, in this particular instance, we have a situation where the vehicle, the prior owner, had aftermarket brake parts. We had a brake pulsation problem, and that was accelerating the wear in this space. So again, this is the reason for swapping those out. Now, let's talk about, got this side loosened. You do not have to remove the ball joint from the spindle or the thrust arm from the vehicle. You can just loosen this on one end, and you can actually press out the old and press in the new with the control arm on the vehicle. I've done this before on others, and it works just fine. One interesting point, this is the mounting bolt, and it is 18 millimeter. It has a flathead fitting on the end. I am not sure why, but what's more interesting is the receiver on this end, or the fastener. It's not a traditional nut. It's actually a threaded sleeve that's pressed into the suspension carrier. The carrier itself is this here, and that threaded fitting, if you look at the back side of it, it looks like a nut. It looks like a nut, and you could put a wrench or a socket on it. It's hard to reach, but you don't need to do that. It will stay in place while you back out the bolt or when you reinstall the bolt. But this is something really different. I haven't seen this before. I haven't done our other F30 yet, although that's coming up soon, but I will be replacing the hydro bearings on that as well. Taking a look at the hydro bearing in more detail, you'll notice that the mounting bolt hole or slot is off center from this aluminum core. and then you have this notch that runs the full length of that slot, and it's pointing towards the spindle. I've marked where on the control arm when this aligns, so that when I install the new hydro bearing, it's in the proper orientation. And that's something that's important. You need to do that. Now, how do you get this out and in while it's still on the vehicle? Now, that's an easy question for me. I own most every suspension adapter set on the market, which just comes with all kinds of fittings, shapes, and sizes. And I just go to those kits and I pull out the pieces and parts that I need. The only thing that doesn't come from those kits is something like this, where I'm just using hardware from the hardware store. It was Home Depot or Lowe's, I can't remember, but you know, I've got some washers here. I've got a bolt that will fit through the center of the hydro bearing, and then of course I've got this long nut, which is excellent for the kind of forces that you're going to apply to that bolt to remove the bushing. That's really it. That's all that you need to know. I have a little comparison here before moving on. This is a BMW F30 hydro bushing. This is a Mercedes-Benz W212 hydro bushing. This is a little bit smaller and a lot lighter than this. This is a really heavyweight, beefy hydro bearing, but it's for a much larger car, 4,000 pound plus vehicle. And you would find that same size of hydro bearing in an F10, F90, or G30 5 Series BMW. So in fact, they almost look like the same part. Nevertheless, the story is I did a W212 Mercedes a couple of years back where the owner was chasing a brake pulsation, and the dealer was running him in circles with all kinds of things, you know, rebalancing the wheels and tires and multiple times, multiple trips to the dealer, back and forth. They looked at wheel bearings and rotors and you name it. And it was the hydro bearing. And when I swapped out the hydro bearing, his problems went away. But the dealer could not fix it, could not resolve the issues. I intended to show the part number for the hydro bearings. The part number is the same on both sides. If you're planning to do this job, I hope this helps. I'll place the bearing in the floor, and we'll take a look at the pushing mechanism that I put together. This cap is pushing in this direction. The hydro bearing is still visible. It's the control arm there. You've got the receiver cap. I've got a washer, a couple washers, and some grease, and of course that long nut. Each of these pieces came from 3 different adapter sets. Of course, this center bolt here and nut and the washers just came from the hardware store. Nothing special about those, but this will do the job. The other thing you need to be concerned with is not just the orientation or the rotational position of the hydro bearing when this goes back together, but you need to be concerned with the depth. So make sure that you measure that and you remember the measurement and you put it back in place at the same depth on both sides of the vehicle. Just be aware of that. The first of the hydro bearings has been removed from the driver's side thrust arm, and this is what it looks like with the bushing removed. Take note that you may remove the original bushing in either direction. You can remove it to the right or you can remove it to the left. It really makes no difference. It's entirely up to you. And to confirm, this is an August 8th of 2016 production bushing, and the vehicle is a November 2016 build, so this is an original part. One thing to take note when reinstalling the new bushing is the back side of the thrust arm. It actually is chamfered or beveled. It's really intended as the receiving end for the new bushing. So I have the new bushing here, and I'll place this, and it actually stays in place. If you look on the other side, there is it's just a straight edge. So they really intend for you to install the new bushing from the backside. Now, in the interest of transparency and full disclosure, I had showed in the earlier clip the the parts and pieces that I used to push the original bushing out of the thrust arm. It did not go well, which is really surprising because I've done more of these than I care to remember, and I've never had a problem before. A number of broken spindles, which really in this case are just bolts from the hardware store. I do have and have had a number of hardened spindles, which are part of ball joint kits and suspension bushing removal kits and all those things, but I have broken most of them as well. So I had to get out something a little bit bigger, and I had to go to this, which is interesting because rarely have I used this. In fact, it's just kind of cumbersome to use it, but it worked, so I can't complain. And I want everyone to know that if you're doing this job, what I did in this case was I used this to break the, actually break free the original bushing, and then I could actually go back to the other pusher puller that I put together. That's the case there. If I had a hardened spindle, it probably would have went better, but that was just the case in this situation. So I wanted to make sure I shared that. Moving on to the next step. The hydro bearing has been removed from the passenger side thrust arm. All of the parameters are the same on this side of the vehicle. Take note that you're going to install the new bushing from the back side of the thrust arm, same as on the other side of the vehicle, and that there is a chamfered beveled edge here which allows you to place the new bushing in this groove. It stays in place, and that way you can get the rest of your tools and adapters and things around this and begin the pressing operation. This is the complement of adapters and pusher puller hardware that I used to get the old bushing out of the thrust arm. It did fight me, and I did have a situation where one of the fittings actually slipped. It went inside the ring, and you can see that it kind of started to push the internals of this out the other side, and it made for a major mess. All of the hydraulic fluid drained out, with the exception of what's on the towel. It drained out of that bushing, and because it's black in color, it shows me that it was in need of changing. So it has evidence of wear. When these are new, the hydraulic fluid actually red in color. So this has gone from red to black. The reason I know that is because I damaged one of these many, many years ago doing another suspension project, and yeah, I had a different kind of mess and the expense of replacing a bushing that was brand new. Nevertheless, live and learn, and that's how things go on these types of projects, but this is going really well. I do have the driver's side back in place, and just a reminder, you do not tighten this until the vehicle is at normal ride height, and it's 100 Newton meters or about 76 foot-pounds of torque on that bolt. I just have it loose fit for the moment. I'll get the vehicle, actually, I could do one of two things, right? I could jack up this side at the spindle, or I could just put the wheels back on and lower the vehicle and crawl underneath. Not sure which way I'll do it. Another interesting component is this crash lever, which is found on both sides of the vehicle. It's made out of either steel or cast iron. It's a very heavy component. The bolt for the hydro bearing and the thrust arm actually passes through this and into the suspension carrier. So this is part of SORB, which is structural offset reinforcement barrier. In the event of an offset collision, if there's anything that intrudes into this space, this allows for overlapping protection, and it transmits the energy from anything that hits this lever into the suspension carrier. Again, one of those additional safety components. I actually have the one from the passenger side removed. Again, quite heavy. It feels almost like cast iron, but nevertheless, it's something for added safety, and something that I haven't seen on like the E90s or E46, E36. This is a new item. The new hydro bearings are now installed on both sides of the vehicle. Everything is in its proper orientation and position. And as a reminder, everything should remain loose fit. The securing bolt should not be tightened until the vehicle is at normal ride height. And that will be 100 Newton meters or 76 foot-pounds of torque. Make sure that the crash levers are put back in place and you should be good to go. Some may have noticed that there are boxed rotors at the rear of the vehicle, and I did decide to go ahead and replace those. Just to, while I'm in there, why not knock those out as well, and I'll have fresh rotors on all four corners, fresh pads on all four corners, new wear sensors, new securing bolts, just the whole shebang. I was contemplating not replacing them before, and then I thought, while I'm in there, why not just do it, and I'll have new rotors, pads, etc. on all four corners. Quick note on changing the engine air filter on the B46. So it is 1, 2, 3, 4 clips to take the filter housing apart, which is really convenient because a lot of other BMWs are not so easy to access the air filter, so that's nice. In terms of this filter, it's made by Mall, and that is, as you can see, it's got the BMW logo on it as well. This is probably the original filter, or maybe it was replaced once, but as you can see, there is a dark cast to the filter pleats, especially on this side. I would say someone at either a dealer or an independent shop, they pulled this out and they vacuumed it off and they put it back in because it's pretty dirty. And like I said, this is an original part. Now I'm using this aftermarket part. It's made exactly the same way. It has the foam on the back and the glue strips and all of that. I would have preferred to go with another one of these, but something like a lot of things in supply chain right now are hard to get. It was going to be weeks before I would see this, and I went ahead and just got an alternate. That's it. Very straightforward on how to change this. Airbox is nothing remarkable, and I'll probably clean that out a little bit, maybe shop vac, and then put the new filter in. The front wheels are reinstalled, and the bolt torque is 103 foot-pounds. I've also put the center forwardmost under tray back in place. I've got the corner pieces still on the floor, and those will stay out until I have a chance to properly torque the thrust arms when the vehicle is back on the ground. So those will go in later. In the meantime, I've got the rear wheels removed and the rotors in place here on the floor. Taking a look at the rotors themselves, I've got the securing bolt out, I've got the caliper clip removed, and I'll go ahead and get the other items and just all of this taken apart momentarily. But what I thought before was BMW Factory Rotors, it looks like I was fooled. We know the fronts were not. Those are in the floor here, and they're very ugly. But these may have just fooled me. And the reason I say that is the rust is not what you see on normally see on BMW rotors. Not that they don't rust, it's that this is like a black brown. Typically BMW rotors, when they rust, it's more of a pumpkin orange kind of normal rust color, more like this on the center hub here than what you see on the rotors. The other interesting thing is the swept area, or should I say the lack of swept area. BMW, the pads and the rotors, when they're mated together, they usually, it's a full biting surface all the way out to the edge. And in this case, well, it's not going the full distance, inbound or outbound. And also, take note that the swept area is kind of a black. It's not your typical high polish look that you see on a BMW rotor. And we'll take a look at the M5 real quick. I know this is not the same, but that's typically what you see on any BMW, is very high gloss, almost a buffed surface, very shiny, very glossy. But this is black, and it almost looks like iron, or I'm not sure what kind of metal this is. Yeah, this is not a factory rotor, and I'm so glad that I decided to replace these and go with the factory component. We'll get all this taken apart and take the next step. The The rear calipers, caliper brackets, rotors, and pads are now removed from the vehicle. Let's take a look at the pads, as this is a good point of reference for what's going on at the rear, and the pads are beyond their half-life. They're wearing at an alarming rate, and again, I believe it's because of the aftermarket rotors. This is these are BMW Factory pads. They're the real McCoy, and they don't look so good. In fact, even just looking at the surface of the pad, it's really strange. It's interesting how incompatible this pad is with the aftermarket rotors, but we're going to take care of that. We're going to straighten all this up, get new hardware installed, and move along. Now, the rotors, there's nothing too remarkable to mention here, and this is a traditional pull lever style parking brake. Thank goodness for that. It's so much easier to work on. The rear brake hardware is fully installed, and with the exception of the rear wheels, everything's put back together. I'll get those reinstalled momentarily, and I'll make sure that all of the old brake hardware is taken to metal recycling. That ensures it will not end up in a landfill somewhere, so we'll take care of that appropriately. And as I always mention, make sure that the brake wear sensor is routed properly. You have a clip here, you have a clip here, one here. Coming around to this side, you've got the white clips, and all the way up into this weather pack where it plugs in. So just make sure that this, I shouldn't call that a weather pack, it's not, it's actually just a connector box, but make sure that it's plugged in properly here. Make sure that it's snapped in here. If it is not, you will not be able to reset the service reminder. And if the system cannot see the wear sensor down the line, if it can't see it, then you'll have an entirely different kind of problem. Just something I always like to point out. I did order new spring clips, and just like the ones in the front, they are on back order. So just one of those supply chain issues that everyone is facing right now. Everything looks good here. The other side looks the same. Yes, I'm a little overzealous with the pad compound. You don't have to use pad compound. There is anti-squeal or anti-noise cladding on the outside of the pad, so it's really just up to you. It's something I've done forever, so I continue to do it. And again, that is a 16 Newton meter tightening torque on the rotor bolt. Otherwise, we're good to go here. We'll get the wheels back on, and there's some other small things in this first phase of maintenance. While working on the F30 330i XDrive today, I thought it was a good opportunity to address a question that I receive frequently, and I know there are a number of folks that are curious as well. What are the engineering differences between a 3 Series BMW, such as this vehicle, and a 5 Series, such as this one? And it really comes down to, the answer is actually complicated, but it really comes down to a couple of things. Architecture is in part what are different across the platforms, but the real difference, or the real differences, are in the materials used. And I'll provide examples. Here on the 3 Series, we have a steel lower control arm, we have a steel upper control arm, we have a steel rear cradle, a cast iron rear differential with the exception of this aluminum carrier. That's what you're going to find under most any 3 Series. Lots of steel in the structure, the chassis, the structure, and in the suspension. On the 5 Series, almost all of those components are aluminum. And the really big difference is in the rear carrier. Again, the rear carrier on this vehicle is steel. On the 5 Series, it's hydroformed aluminum. This is something that BMW innovated in the late 90s. It was brought to market with the E39 5 Series in 1997, and it is now the de facto standard across the industry. Mercedes-Benz uses this in the E-Class, Audi uses this in the A6 and above. It's the de facto standard. Now, why do they do that? Why do they want to do that? Well, first of all, aluminum is stronger than steel. Everyone knows that. And aluminum does not have memory, whereas steel has memory. what does all that mean? Well, when you're rolling down the road, when the vehicle is actually on the road, aluminum will absorb and dissipate vibrations and harshness and all those things much more quickly than steel. Now, aluminum is more troublesome from welding and in manufacturing. It requires different techniques, but it is lighter and it is stronger. Also, on the 5 Series, there's a number of exterior components such as the doors, the front fender, the hood, and the rear trunk lid, which are all in aluminum. The rest of the chassis is kind of a mixture of varying strengths of steel. There's some aluminum in there as well. The front shock towers are aluminum. The rear shock towers, partial aluminum and partial steel. It's a mixture. On a 3 Series, all of those components are done in steel rather than aluminum. So that's the really big difference. Architecturally, the vehicles are similar. There are some differences on the 5 Series side, but that's way too much to get into on this in this video. The other interesting part of this conversation is how differences in materials relate in the Tesla line of vehicles. The reason I bring this up, there are a lot of parallels. The Model 3 and the Model Y, they're very steel intensive in the chassis and in the suspension. There's some aluminum mixed in, don't get me wrong, especially in the motors and the drive units and all those things. But if you step up to the Model S or the Model X, completely different story. A lot of the suspension and a lot of the chassis, in fact most of the chassis on a Model S and Model X are crafted in aluminum. And a lot of the suspension members, especially like the lower carriers and things like that, they look like they came or like they would come off of a 5 Series BMW. So that's kind of how things are going in the automotive world right now. You get what you pay for. The higher up the pay scale, or the price scale, I should say, and that's how they're mixing and matching, or I should say upgrading components as vehicles go up in price. The next step in the project is a brake flush. To access the brake reservoir at the master cylinder, you will need to remove this triangular cover panel, which is held in place by 3 10mm plastic fasteners. Give those a quarter turn and you can lift the panel straight out. What I found after removing the panel is that the reservoir and pretty much this whole area was covered in brake fluid. First time I have ever seen or had anything like this happen before. And granted, I did a full brake job, all 4 corners, rotors, pads, and in doing so I had to compress the piston at each of the calipers. However, the real problem, or the root cause of the issue, is that the last person to do brake service and to do a brake flush overfilled the reservoir. It was completely at the top, topped off, as clearly marked on the side of the reservoir. The max marking is down here. So that provides plenty of headroom in the top of the reservoir for brake service. In this case, the last person, whoever did this, they topped off the reservoir, so that created an unnecessary mess. Nevertheless, I'm using this Motive power bleeder. I've had this for 25 plus years, and the only thing I've replaced is the hose, as well as the rubber gaskets where they seal at the reservoir. And I have a whole set of caps for this for a variety of different vehicles, but it is under pressure currently. You want to keep it around 10 psi. I think I have it at 11 or 12 there, but you know, keep it at 10 psi or above. Do not worry about air in the line here. That doesn't matter whatsoever. And then what I'll do after I get done bleeding the system is I'll go ahead and take a syringe and I'll extract some of the fluid here and bring it down to the level where it should be. My brake fluid of choice in every vehicle that we own and for the past 30 years is ATE Type 200. Now it says racing quality. This is not racing fluid. This is really the street product. The racing or track duty fluid is, it's actually this Type 200 Super. And they make others. They make DOT 5.1 and SL6 and on and on and on. But this is the Type 200 DOT 4 that goes in all of our vehicles. Big endorsement there. Got my jug ready, my hose, and I'll go to each of the wheels and start the bleeding procedure. Moving on. The brake bleeding is complete. Did run into a problem with one of the bleed screws, actually the first bleed screw on the passenger side right rear wheel. Apparently someone thought it would be nice to use an impact wrench on that. Nevertheless, I was able to break that free, and the others were actually over tightened as well. And that's probably the sign of an independent shop that really, the mechanic did not know exactly what they were doing. Nevertheless, I've taken care of that and everything's torqued properly and back in place. I had to deal with this situation where the reservoir was overfilled and I used a syringe to remove the fluid that wasn't needed to get it back down to this max level. It's hard to see, or you actually can't see the fluid in the reservoir like this, so I usually stick an LED flashlight to this, and then it lights up the whole reservoir and you can see exactly where the fluid is and you can work it. So again, use one of these hobby or craft style syringes, and preferably one that you have dedicated for this use, not one that you cross use with oil and other things, because I have other syringes I use for oil and other fluid. Anyway, that is the scoop. We'll put the cover back over the reservoir and call the brake bleeding complete. A couple more things to do to this vehicle and it goes out the door. Phase 1 complete. And we'll come back to phase 2 in a couple weeks. The thrust arm bushings, aka hydro bearings, are now properly torqued. Let's talk about this just for a moment. I have the vehicle on the floor and on ramps. I also placed ballast at the front or nose of the vehicle to counteract some of the pitching motion that occurs when you pull any vehicle onto a set of ramps like this. And the goal is to get to normal ride height or as close as possible before you tighten the thrust arm bushings. Why did I not do this on the lift? A lot of people do. I could have compressed the suspension and just did it in that manner while it was still on the lift. And the reason is safety. I've seen people do this before. It kind of creeps me out because if you compress any corner of the suspension on this vehicle, or for that matter any other vehicle that we own, it will cause the vehicle to lift up off of the jack pads and it starts to cavitate on the lift, which to me is super sketchy. I don't want to end up in urgent care or damage a vehicle or what have you, so I'd much rather just put it on the floor, put it on ramps, crawl underneath, and take care of business. Now, let's take a look at the underside. We'll look at the driver's side here. And as you can see, the securing bolt, easy to access. Easy to hit this with a torque wrench, no problem at all. It's 100 Newton meter tightening torque, 76 foot-pounds. It feels like when you hit that number that the bolt is starting to bottom out. So it's pretty easy to achieve that torque without any trouble in the way that I did it. The other thing to be aware of is this connector. Make sure that you plug in the temperature sensor. A lot of people would think that, well, that's just the sensor that provides outside air temperature to the instrument panel, and well, that is partly true. It also interacts with the DMEs. If you fail to plug this in, it will not only show negative 40 degrees on the instrument panel, but it will send that same information to the DME, and then not straight away, but in a couple of days, you will have error codes. The vehicle will start flagging codes and you'll get a check engine light at some point. Again, not straight away, but in a few days. Just make sure you plug this in. Really simple thing to do, but easy to forget. The next order of business is to swap out the charcoal activated cabin air filter. If you haven't done this job, your life is unfulfilled. I say that sarcastically because in the prior generation 3 series, E90, E46, E36 generations, The filter was under the hood, easily accessible. You could swap it out in 2 minutes, no fuss, no muss. It was just easy to do. Ditto for prior generation 5 series such as the E60, E39, and so on. The filter was under the hood. In the newer generation cars, the F models, so F10.5 series, F33 series, and even on up into the current generation G20, G30 generation vehicles, the cabin air filter is under the dash. I'm crabbing and I'm complaining, but it's harder than it needs to be. You will need a shop vac or hand vac to clean up the debris, because there will be debris that comes out of the filter housing. You're also going to need something to kneel on, so save your knees. In terms of this job, it is easy. It's just more trouble than it needs to be. You have a 10mm. I actually have the nuts removed already. There's one here, and there's one over on this side. Of the dash disassembled at the passenger side footwell. Let's take a look at the filter enclosure, which is curved. It's kind of banana shaped, if you will. And we have the bottom cover, which snaps into place, and then it's further secured with two T20 Torx screws. This is the light connector, and there is no 12-volt power provided in this space. It's probably just due to the way the vehicle was optioned. Now, let's look at the filter that came out of the vehicle, and it's not the worst. It's not the worst I've ever seen, but it is quite dirty, and if you open the pleats, you can see there's a lot of dirt and debris. This is beyond its useful life, and it needs to be replaced. So we'll do just that. We'll get the new filter in and everything buttoned up. Very straightforward. If you've ever wondered where the subwoofers are on a modern BMW, such as the E-Series or the E90s and the F30s, and I'm presuming on the new G models as well, the subwoofer itself is placed underneath the front seats of the vehicle. I really like this. They've been doing this since 2006 when the E90 generation came to market. Great effect. You know, so you've got sound literally on your backside, as they say. I like that. We'll get everything put back together and wrap this up. One other important point is when installing the new filter, you want to make sure that the airflow is going in this direction. That is, the filter itself will typically have an arrow pointing in the direction of airflow, and you want to make sure that it's installed in that orientation. Make sure this drain tube is connected. That takes care of any condensation. And if it's disconnected, then you're going to have wet carpeting and a wet footwell here. The new brake rotors and pads are fully bedded on the 330i XDrive. If you are unfamiliar with the bedding procedure, it is as follows. You want to find an open stretch of road, preferably one with little to no traffic. From there, you're going to perform multiple hard braking events, and you're going to do those in succession with very little time and space in between. The first two will be from 45 miles an hour down to 0, and then you're going to perform 8 to 10 hard braking events from 60 miles an hour down to approximately 15 miles an hour. But you want to ensure that you don't come to a stop. You want to keep rolling, accelerate back up to 60, and again get on the brakes hard until you get through 8 to 10 of those back to back. Now in doing so, you're going to put a lot of heat into the brakes. You're going to clean off the top surface of the rotors, but the overall goal is to really mate the new pads, the surface of the new pads, to the rotors and have edge-to-edge contact, 100% pad and rotor contact, and that is really going to ensure that you have the most efficient and effective brakes throughout the life of the vehicle. Let's take a look at the rotors, and I've talked a lot about those, aftermarket versus factory. We have the aftermarkets here on the concrete driveway, and have a look at the factory rotors. See a difference? The factory rotors, the swept area is 100% edge to edge. The pads are making excellent contact, and this is going to provide the most effective braking. having a look at these, I don't know what percentage that is. We'll say maybe 60-65%, but the swept area is minimal. And the other thing that's interesting is it's black in color. It's not high polish like you see above. So this is a different type of metal, and again, a metal that's not compatible with the brake pads. I wanted to point this out. There is a tremendous difference between aftermarket and factory. The rears don't look as bad, but you can see the swept area is not 100%. The new rotors look really good. 100% pad to rotor contact. I'm really happy with those. Phase 1 of the 2017 F30 330i XDrive project is now complete. Let's recap what's been done. The engine oil and oil filter have been changed. The engine air filter changed. Ditto for the charcoal activated cabin air filter. The brakes have been refreshed on all 4 corners using BMW Factory Rotors and Hella Paget brake pads, which I highly endorse. The front and rear brake wear sensors also changed. And as part of this project, I also swapped out the front thrust arm bushings, aka hydro bearings. Now this, despite the fact that it's raining, this vehicle is going to get cleaned up, washed, turned over to my youngest son, and in a few weeks time it will come back to me. At that point I'll do what I'm calling phase 2. This will include the cooling systems. There are actually 2 cooling systems on this vehicle, one for the turbo side and one for the engine block, heater core side. It's a split system, much like the F10 M5. However, they're very different in architecture and design. On this F30 with the B46 engine, the turbo side of the cooling system is driven by an electric water pump, and the other half of the cooling system for the engine block, heater core, etc., that is driven by a mechanical water pump, which is a departure from the way things are done on the N20, N26. I'll talk about that in a different video. From there, I'll move on and do full service on the transmission. This is the ZF 8HP transmission, basically the de facto standard in the industry today. I'll do new pan, filter, fluid. I'll do the recalibration and everything using ISTA, and we'll be good to go. This will also include, or phase 2 will also include, the rear differential, the front differential, and the transfer case. It's a lot of work, but it's good to refresh all the fluids in each of these components, and just to make sure that I'm, in essence, hitting the reset button on all the serviceable items on the vehicle. If I think of anything else, I'll include it, but for right now, that is a wrap on this project. I hope this was helpful.